A few folks have asked what it's like to shake castings out of the sand, so I thought I'd make a video today to give a little insight into that. This is a 36-inch camelback casting that I made yesterday. The whole flask and sand plus the iron in it probably weighs something on the order of 400 pounds. And the sand is, after the casting, pretty firm here. It's dried out some and hardened up some just from the heat. But it's possible to grab hold of the bolts here that put together and rake the sand and pull that top coat off the drag. We'll tip it off here, hopefully. Oh, it's caught on one of the guide pins, so I have to come back over here a little bit. Right here, it was caught on this guide pin, so there we go. Now it'll come off. So yeah, that's the cope, and these bars here help support the sand when I'm molding. Pull off some of the sand here. You can see in places where there are little stems of iron that came up. Those are vent holes that filled with iron as I was pouring the casting. So let's go ahead and pull up on the casting now, see if I can break it out of the sand underneath. So, and then we'll just tip it over this way a little bit. Excellent, good. Here's actually the separation plane between the cope and the drag. You can see that light colored sand in that separation plane. And you see a lot more of those vents. I put vents pretty frequently along the mold there. That helps let the gas out that forms as the hot metal hits that moist sand, and that lets the metal into the mold better. A little bit of flash here along the seam where some of the sand broke out as I removed the pattern from the mold as I was molding the sand. And then here you can see the main casting, of course. Here's a riser that supplies hot metal to the casting as it cools down. And actually, this mass of metal here keeps this end of the casting hot, so that when the mold is filling, this end is down a little bit. I have the mold inclined slightly with this end down, that end up, so that the metal fills from here to there. This metal down here at the very end is going to cool off the quickest. This is going to cool off last, and there's contraction the whole way, so that some metal gets sucked in out of this riser to a varying degree as the metal cools in the mold. If I don't use a riser, I can get vacuum defects in here that people refer to sometimes as porosity. This right here is a filter that filters the iron that I fill in the pouring basin, comes down through the filter, and then around through the runner, up into the riser, and through the gate into the mold. That's pretty much what there is to see. After this, I'll put it up on the bench and get a wire brush out, a hand wire brush, and just brush it and blow it off, and then it'll go to heat treat for stress relief.